Hello, this is Mrs. Sargent, and this is lesson 4.5, Lewis structures, the basics. Today we're going to talk about single bonding in Lewis structures, and if you'll remember to our last unit when we talked about electron dot structures, we found the number of dots from the valence electrons. The valence electrons are used in Lewis structures of covalent compounds. So a Lewis structure is a diagram representing a covalent molecule or compound, and it shows all the atoms and all of the valence electrons, both bonded and unbonded. So we have silicon tetrabromide and nitrogen trichloride. The bonded electrons are shown with the lines, and the unbonded electrons are shown with the dots. When you have a pair of dots, that is called a lone pair. So the steps to draw a Lewis structure. The first thing that you need to do is you need to count all of the valence electrons and record the total. Secondly, you need to arrange the atoms, and then you need to single bond everything and subtract the electrons from the total. One bond equals 2 electrons. So a bond here has an electron at each end. So if we have a diatomic molecule of hydrogen, there is an electron at each end of the bond. The fourth step is to count the number of electrons needed to complete the octets, and if you have enough, you're going to apply the dots. So our first example is H2O, or water. So we have 2 hydrogen atoms. Hydrogen has 1 valence electron. We have 1 oxygen atom, and oxygen has 6 valence electrons. So this is going to give us a total of 8 electrons. So I always put the number of atoms on the outside of the parentheses. Number of atoms, and then inside the parentheses I put the number of valence electrons. And then this is my total electrons for my Lewis structure. So, when you arrange the atoms, you want to put the atom with the least number, the element with the least number, in the center. So because of this, I'm going to put oxygen in the center of my molecule. And I'm going to put a hydrogen on each side. We also want to try to make it symmetrical if possible. So that's why we're doing this. Now, so that we've counted our total number of valence electrons, we've arranged our atoms, and now we're going to single bond everything. And we have to subtract the number of electrons involved with the bond. So we have 2 electrons here and 2 here for a total of 4. So we're going to subtract that from our total. So we have 4 electrons. Next, we need to count the number of electrons needed to complete the octets. So every atom wants to have 8 electrons except for hydrogen. Hydrogen only wants to have 2 electrons. So hydrogen is always going to be taken care of when it has a bond. So we're going to look here at oxygen. Well, oxygen has 2 electrons here and 2 here that it is sharing with each of the hydrogens. So it has a total of 4. So oxygen needs 4 electrons. So we have 4 and we need 4. Anytime that this zeroes out, then we can, because we have enough, we can just apply the dots. So we're going to put 4 dots on oxygen. You're never going to put them where the bond is, always on the open sides of the atom. And so now we're taking care of our last step. So we have a few more examples here. We have oxygen dibromide and nitrogen tetrahydride. So we have one oxygen atom. Oxygen has 6 valence electrons. We have 2 bromine atoms. Bromine has 7 valence electrons. So 6 and 14 for a total of 20. We're going to put oxygen in the center because oxygen has the least number, and we're going to put a bromine on each side of it. Now we're going to single bond our atoms. We've single bonded those. We have 2 4 electrons, so we're going to subtract that from our total. So we have 16 electrons for our Lewis structure. Now we need to go back and we need to assess our needs. I like to keep a tally as we're going through this. So bromine has 2 with the bond. To get to 8, it is going to need 6 more. Oxygen has 2 4. To get to 8, it's going to need 4. Bromine has 2. To get to 8, it will need 6. So then 6 plus 4 is 10, plus 6 is 16. So we have 16 and we need 16. So this is going to zero out. If this doesn't zero out, you need to go back and check your math and check those that you have set are bonding, and to make sure you didn't make any mistakes. With single bonded molecules, you should always zero this out. Our next lesson, we'll talk about what happens when that doesn't happen. So since we have what we need, we're just going to apply the dots to our Lewis structure. So that takes care of oxygen dibromide. Now let's take a look at nitrogen trihydride. We have one nitrogen. Nitrogen has 5 valence electrons. We have 3 hydrogen. Hydrogen has 1 valence electron. So 5 and 3, that gives us a total of 8. We're going to put nitrogen in the center of our compound because it has the least number. We're going to arrange the hydrogen around it. Now it doesn't matter where I put this 3rd hydrogen because no matter how I turn my molecule, it's always going to look the same. Now I'm going to single bond the atoms. 2, 4, 6 electrons are taken up with my bonds, so I'm going to subtract that from my total. So I have 2 electrons. I'm going to go back and I'm going to assess the needs. Hydrogen, all of my hydrogens have a bond, so they're taken care of. Nitrogen has 2, 4, 6, so it is going to need 2. So I have 2 and I need 2. So since I have enough, I can just go in and apply my dots. I want you to pause the video and take a look at CH4 on your own. Welcome back. Let's take a look at CH4. We have 1 carbon. Carbon has 4 valence electrons. We have 4 hydrogen. Hydrogen has 1 valence electron. This is going to give us a total of 8 electrons for our Lewis structure. We're going to put carbon in the center, and we're going to place the 4 hydrogen around the carbon. We're going to single bond all of our atoms together. 2, 4, 6, 8. So we do not have any electrons. We have 0. We know that all of our hydrogens are going to be taken care of because they have 1 bond. So now Carbon has 2, 4, 6, 8. It does not need any, so we are done with methane here. C3H8. Now, we don't have one that just has one atom, but carbon is still going to go in the center. Let's first calculate our total number of electrons. So we have 3 carbon. Carbon has 4 valence electrons. We have 8 hydrogen. Hydrogen has 1 valence electron. So 12 and 8 gives us 20. So now we're going to put our carbons in the center of our compound. And then we're going to arrange our hydrogen around it. Then we're going to single bond all of our atoms together. So now let's count up how many electrons are taken up with our bonds. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we don't have any. We have 0 electrons for our Lewis structure. All of our hydrogens are bonded. And if carbon has 4 bonds from it, it is taken care of. So we do not need any. So that Lewis structure is also done. So sometimes you will have Lewis structures where you will not need to apply any dots. And that is happening with both of these carbon molecules. Lewis structures of polyatomic ions. A negative ion or an anion, you're going to add electrons because you're gaining electrons. With a positive ion or a cation, you're going to subtract electrons because you're losing electrons. Then we have to place the entire structure in brackets and put the charge as the exponent. This is what we've been doing, and I've been calling it the ion notation. So we have SO4 2 minus and NH4 1 plus. So here we have 1 sulfur. Sulfur has 6 valence electrons. We have 4 oxygen. Oxygen has 6 valence electrons. 4 times 6 is 24, plus 6 is 30. We have a negative charge, so we're going to add 2 electrons to our total to get a total of 32 electrons. Sulfur is going to go in the center because it has the least number of atoms. I'm going to move this oxygen over a little bit. Now we're going to single bond all of our atoms. 2, 4, 6, 8 electrons is taken up with our bonding. 32 minus 8 is going to be 24. So we have 24 electrons left for our Lewis structure. Now we need to go in and we need to assess the needs. Oxygen has 2. It is going to need 6 to get to 8. Oxygen has 2. All of our oxygen are going to be exactly the same. Sulfur has 2, 4, 6, 8, so sulfur doesn't need any. So 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. So we have 24, and we need 24, and that is going to zero this out. So now we can apply our dots to our Lewis structure. Let me move this oxygen up a little bit. Don't have room there. Let's see. There we go. So sometimes when you are drawing your Lewis structures, you may need to erase, and so you have enough room to make them a little bit neater. So now I've applied all my dots. Now I just need to put it in ion notation with the brackets and the 2 minus charge on it. Our next polyatomic ion is NH4 1+. So I have 1 nitrogen. Nitrogen has 5 valence electrons. I have 4 hydrogen. Hydrogen has 1 valence electron. So that is going to give us a total of 9. We have a positive ion, so we're going to subtract 1 from our total. So we have a total of 8. Nitrogen is going to go in the center. Our hydrogen are going to go around our nitrogen. We're going to single bond all of our atoms together. 2, 4, 6, 8 is involved with our bonding. So we have 0. Each of our nitrogen or each of our hydrogen have a bond. So they're taken care of. Nitrogen has 2, 4, 6, 8. So we have 0 and we need 0. That zeroes this out and we are done. Except for putting it in ion notation. So we got to put the brackets around it and then put the charge 1+ on the outside. So that is our Lewis structure of polyatomic ions. And that concludes our lesson for today. You have practice the basics in your packet that you need to take a look at. It is very important that you understand the basic Lewis structures before we move on to double and triple bonds because it's going to get more complicated. Please come and see me if you have any questions. Thanks and have a great day.